Okay, so I believe you can download the extension pack because the link for the extension pack is given in our workshop website. So after you download that extension pack, you can go to the VirtualBox tools. Okay, in the tools there is something called preferences. Go to the preferences, and here there is a tab called extension. So you can select that one and you can add the extension pack using this button. Now you can see I have already added that extension pack to my PC. So what you have to do is you have to click on this button and you have to go to where you download the extension pack and you have to open that one. So that is how you're going to install the extension pack. And for our in the first session, Mr. Lalanta will explain you about the SNMP protocol, Simple Network Management Protocol, which is used for network monitoring. So after discuss about the SNMP, then Mr. Tuan will start with the installation of LibreNMS monitoring server. So with the VirtualBox, when the Mr. Tuan start his session, you have to switch on your monitoring server. And to log into that monitoring server using GUI, you have to have the Windows XP as well. Not only that, you have to run the Dynamips and Dynagen file, which you have already created, because network connectivity should be there. Otherwise, you can't connect to the LibreNMS or any other devices, because using the monitoring server, we are going to monitor Cisco routers as well as pfSense. So make sure that those devices are switched on while you are configuring the LibreNMS practical. But for the morning session, while Mr. Lalant is explaining about the SNMP, those devices do not need to switch on. So still, if you have any issues with network connectivity, let us know. So I hope Mr. Vijayaratna has got the idea. So how to install the extension pack. Okay, so if you don't have any problem with the installation of the extension pack, Mr. Lalanta will start his session. So I'm going to hand over the session to Mr. Lalanta.
Hi, good morning, everyone. I hope you can see my presentation. Okay, let's start today morning session with SNMP. Actually, uh, even though some of maybe you are not using this, but why? Mute, unmute. Ah, and I think you have most of you maybe may have used this protocol already and knowing for many years, or although maybe some of you may have even read about this when you read in technical articles about this. This is a monitoring protocol. This is a very old protocol, but still widely used in many applications. Uh, so, what is actually the definition of SNMP? It is an internet actually. It is a protocol. Internet is standard protocol for collecting and organizing information about managed devices on IP networks and for modifying that information to change device behavior. That is, this is used for mainly for collecting information from other devices, that actually the information that we need to monitor and manage our network and other equipment. That particular information is collected, and those are kept in an organized form, that information. And also this protocol can be used to modify the device information, like device configurations, or some device port status, like we can shut down port or open port, up port, like this. And also normally there are two methods of communicating uh, this protocol with the devices. One is we call polling. Actually, polling is done by the SNAP manager. There are two components. I will later more in more detail. I will explain about. There are, it's like a client server model the SNAP protocol works in, and the one we call manager, SNMP manager, or network monitoring station, or network monitoring system. That is the manager component. So that's the one who requests for information and collect it from devices and display for the user. And other part is the agent. So agent is the device that, or the agent is the application or particular device that we need to monitor, maybe a switch or router or server, something. So normally there are two operations mainly we can polling and traps. Normally we can poll devices. That means the manager polling means uh, periodically it requests for some information, maybe the system name, maybe the system uptime, device uptime, for whether there's some we need to get some traffic counters from the network interfaces. We do poll, that is periodically request information from the device, that is called polling. The other thing is the the uh, the device, particular device that is being monitored will send uh, traps or that traps means actually when some event happen in particular when some significant event happen in particular device or service, meaning that some device interface is down, or whether some error is happening, or some configuration changes has done to the device, or if it is a service, maybe service status has changed. So if something like that happen, actually we need, as network admin, we need to know about that. So we need to get information about that. So in that case we can configure that device, so some service to some send events or information to the manager when such event happens. So that those are called traps. Uh, and there's actually another version that is inform. That is, there are two types of such event brought event dispatch to the manager by the device or service. One is traps, the other one is inform. So I will also explain that later. So again so we can use this protocol to change the device status, like as I said, change interface to down or up, to some do configuration copy to maybe Cisco some router switch, likewise. And then this is again an industry standard protocol. That means since this is standard protocol, this is widely implemented by many vendors. Actually, almost all network device supports this SNMP protocol. And also some maybe for example, if you want to monitor some service like MySQL or something, actually there are, even those are we sometimes somehow we cannot find the develop SNMP modules, agent modules by the vendor itself, but we can find somehow sometimes third-party modules developed for and monitoring those applications too. And this protocol runs on application layer of the OSI model. Uh, so like email, the SNMP, that is SNTP, like NTP or application, other application layer protocol. This also runs on application layer. And this normally this protocol uses the UDP ports, and those are 1611, 162. So uh, the 161 port is mainly used when we are doing polling requests. That is, manager request periodically from the agent for information. And when the manager receives traps or informs. Port 162 is used on the manager to receive that information. So this is the history of actually this was uh, first uh, released in 1988, the version 1, and uh, actually it is very we will discuss later on these differences of versions. Very basic version and not does not support many operations. So and also next we the version 2 came to the came, and actually the even it is version 2. Currently we are now using is the version 2c, the some subversion. So it is actually the version 2 is still widely used. Maybe the most uh, mostly used version still will be the maybe the version 2. uh, Actually, uh, I don't know actually the reason, but because version 3 is more secure, uh, but still version 2 is being used by the administrators. And so version 2 version 2 does not support actually authentication and privacy. Privacy means encryption. So still in version 2, the SNAP messages are passed in plain text. So if someone in the middle can is going to view, he can display the SNMP passwords and things information. So what it can do, mean how it can be used. Uh, it can be used to monitor uh, or manage network devices and other servers and other software applications. And we can get the, for example, device status, like it is up down status, and the interface bandwidth. Actually we can normally even in learn we use SNMP based tools to monitor the network band traffic usage that is used by the institute. uh, for that there are some something called interface counters. So uh, for particular interfaces, so those counters are incremented, and using the tools like Cacti, Librin, MSO, Nagioso, even the Zabbix, we can get the uh, traffic uh, bandwidth of network interfaces. And we can also get the CPU usage, temperature, like any supported parameter by the device. And when think about the servers, we can get also PC's workstation. We can get the hard disk utility, hard disk actually utilizations, and what are the installed application processes. And if it's a software, we can get the memory it is being used, and many things. If we can develop our own SNMP module, sorry, SNMP module, uh, we can also we can also customize to any application information what we need. Also like CPU load average and things can be received from computers and servers. And also if it's a network, not only network devices and other servers and things, even the some print, if the some printer supports SNMP, we can get the ink level or some paper tray, the it's whether MTO for the status, and if it's a UPS supported the SNMP, there are many UPS brands and normally corporate brand uh, uh, things used in our officers are supports SNMP. So we can get the UPS parameters with the backup power level and the other maybe voltage level and current level things. And this is the architect. And there are. I will show this diagram for before going through the previous slide. This is the SNMP architecture. So this left side NMS that is the network monitoring station, or the manager, we normally call manager, or normally NMS is something like in a lib, if it is a monitoring tool like LibreNMS or Cactio, so we can call it a network monitoring station. So the manager component is built in those monitoring tools. So the managed device is the device or the network or server equipment. So agent is uh, running on that device. So normally we can it's like at the actually SNMP service or daemon in Linux we can call the daemon process. So it's always running. Uh, that is waiting for some request from managers to service or give information. So this is these are the uh, three components manager, that is NMS, or the monitoring, maybe monitoring tool. Uh, as I said, there are tools like Nagios Cacti, Sabix, MRTG, multi-router graphing tool, like things, and agent is the normally we can also call the particular device, or we can also call the particular firmware or software running on that particular device. Maybe if it's a router, we can call the operating system. If it's Cisco iOS, or if it's a PC, it's a Linux. Uh, some process is running on the Linux server. So SNMP daemon is running on the server. So that is basically called the agent. So MIPS, the third important component is we didn't discuss it so far. Is the management information base. That is the specification containing the management information of that device. That is, it's like a directory. So if we develop a MIB, it's actually text-based file. So it is actually text-based file defines if it is, for example, take a router. So in MIB, we can define what are the interfaces. So what variable, or what are like attribute file. Uh, so so we can get interface. There are variables, so there are objects. We'll call it objects. There are objects uh, describing the uh, those interface like things. So interface index, and there are also some data types associated with them, like counters, like things, uh, strings, like things. So it is we normally call it object. Sometimes some people call it variables. Like, as you know, in programming we have objects and variables, and they have associated data types. Like, so it's a basically directory. Uh, so actually MIBs, we as we can see, normally MIB is inbuilt to the managed device. So with that MIB, it is it has it is storing particular data, that is information as well. Also, we can keep this MIB in the manager device, so that we can actually resolve uh, names. Actually, there are in MIB, there are normally, we'll see later, now numbered, this object has a OID, that is object identifier, that is a numbered number, that is a dotted line number, hierarchical number. So it has a map name for that MIB object. So for example, uh, yeah, this like in this example, as you can see in the last line, there is a sys name, right? So there is a for this OID object. For this object, there is a corresponding textual name representation. So we normally call it label. The left side here, in case sys name, it's a label. So we also can it's the object, and right side is the object identifier, that's a numbered one. So we also know that computers and software application don't understand the names, or so it normally go with the numbering. So likewise, here is the object identifier, that is a hierarchical notation, numbered notation for identifying particular objects. So likewise, normally in NMS we can keep MIB, but it is not essential. So uh, we can also request or get information from the agent uh, using this OID numbered name, so that we don't need to MIB. But in practical situation, we get those information from the name, like system. Give me the sys name. The manager the agent. So we don't use the number, because even the computers can manipulate the number system. Uh, People can't remember the numbers. Only we get the it is easy to remember and remember the names. That's why we keep it might be in the client side. So client side means actually the manager. So this is like also we can compare this as a client server model. Actually, this is a client server model. The client requests for information and the server provide information. So basically, there are currently 7 operations. These are like we can also call operations, and to get 10, set 10. So information of the target device, that is a monitored device. So we also call these video types, protocol data unit types. So the first one is the get request. That is the uh, we, that means manage. This is operation usually executed by the manager from the agent. So that's why the manager to agent arrow there. So it is not going, that command cannot be executed from agent to manager. Uh, when in the get request, we can query query for a value. Like we can ask, give me the sys name, or give me the interface interface number, give me the interface status, like thing. So give me the CPU usage, like thing. So through get request, we can get or ask agent to give the information. The next one is get next request. That is also going from manager to agent. So think imagine there are normally two types of objects, two types of objects in SNMP, that is data, I mean data structures or something. One is normal single value, other one is table or list, like something. So in a table or list, there are multiple values. That is, if we ask for um, if we ask for interface counters or interface packet counters from a router, there are few interfaces, right? So if we request, it will in response give a table or list, something like. So in that case, if you first get the index one, that is interface number one value, then this get next request will give the interface index number two traffic counters. So that is used to get the next coming data of the same table. So in next operation, get bulk request. So in that one, uh, it is also manager to agent request. In that one, we get multiple iterations of get next request. That is, uh, we execute multiple. Actually, we get one by one of the all values from a table or list there. And in next one, the fourth one, the response. Actually, response is the answer or the information sent in response to the request by the manager. So it is going from agent to manager, and so those are generated in response to above request, that is number 1, 2, and 3, that is get for the get request, and also for set request. If the set request is successful or whether it's a failure, that particular message will be sent in response. So fourth one is set request, that is also going from manager to agent. When we need to modify a value or set some object value, so we won't need to change there are there's a call variable syscontact, that is contact for that particular device management, that is the network admin contact normally we put there. So if you want to change it, we can do a set request. Also, if you want to shut down interface, we can do that using a set request. And also, if you want to assign nodes, some add VLAN for a switch, we can also do a set request. Likewise, we can write write into the device or modify the device values objects by this set request. So next is the trap. Trap is the, as I said earlier, uh, 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 some notification in an event, significant event, like a link down or temperature warning, and that is sent by agent to manager. And next is inform request. Inform request is also same as trap, but the difference is it is reliable because if the agent send a trap request to trap to manager, that is something has happened, but the manager sometimes won't get the packet because it's UDP. It may be dropped somewhere, and manager don't know what has sent. Also, agent don't know whether that has been delivered to the manager successfully. So in that case, inform request has made the operation has been created. That is reliable, even that is UDP. Uh, that manager in response to trap, manager will send the agent the acknowledgement like TCP protocol, like send acknowledgement, so that that agent know that it has sent to the manager successfully. So this is the we discussed about MIB management information base. It's as I said, it is some specification defined in a text-based file. Also, it defines management information of the devices. Management information means those particular information what we need to manage that device or monitor that device. So it is a text file. Uh, it is there's a notation called SN.1 notation, and it is described or written in that notation it's kind of like a language. You can call it like a language for formatted text. By reading that text file, any application can um, uh, read it and request for or agent request agent for information or something like that. And so it is also hierarchical. Hierarchical mean like a tree structured way. That is, there are layers, top top one and but it down layer like it's tree structure. So tree structure means actually, if I visually show, this is this one. It's a it in this this is the actually MIB some diagram showing that OIDs and actually the names or labels uh, in hierarchical manner. That means this hierarchical manner that mean it can start from actually this is since this is a uh, since OID is dotted numbered system, so it is beginning from actually it is read from left to right. That is here uh, in this slide, as you can see, we can this for example, this is name system starting from dot and 1.3 dot like it is hierarchical. So three here, three is a sub sub subdirectory of 1. 6 is a subdirectory of 3, like that. That is why it's called hierarchical. So in this way, uh, we can define the available MIPS in this diagram. Okay, so there, okay, we will come to this later. I wanted to show you what is actually hierarchical. So also it's like we can call DNS. The best example we can get that to explain this MIB, that hierarchical thing, is DNS. We have the LK domain, and also AC is a subdomain of that, and PDN is a subdomain of that likewise. So this is numbered one. Numbered notation is also some. It is also hierarchical, and that actually corresponds to that particular textual representation. So again, okay. So this each entry is normally we call a object. Most time we call object. Somehow sometimes it is called also variable. So object has actually value, can have a value. So again, this OID, that is actually that variable object, that is normally we earlier we said the sysname or syscontact or like things like those objects. So those have a relevant object identifier which is unique. So this is example of object identifier. So it is separated by dots. Uh, so and it is starting normally it start with the dot. It is read from left to right. So top of the hierarchy at the left side, and when it goes down, uh, goes right way, it comes to the particular object we need. So it has a, yeah, this, as I said, this each this each label or has a corresponding number. ISO actually ISO is represented by 1, OG is represented by 3. Right? So as I said, MIB has normally 2 object types. One is scale object. Like I said, it is something like single value, and actually it has a single instance of value, single instance, and sysname is an example for that. So since it has a single instance, normally there will be only 0 index. Otherwise, if there are 3 entries, it will have 0, 1, 2. Normally, the index is starting from 0, not 1, 1, 2, 3, or not like that. It is normally the indexes are started with 0, even for interface or anything. So this is some actually SNMP get. Actually SNMP get, and here you can down see SNMP work something. So these are actually implementations of previously I call the operations. So these are actually standard. This is a standard. This is not an actually command or something. This is something definition by uh, actually this is the standard definition of and standard definitions of basic operations. Uh, these should be implemented by any yeah, any manager application or manager system. So for example, the Cacti developers has to develop some command or some maybe uh, some command or some script or some executable to get to implement this get request operation. So normally we can say here uh, the SNMP get. Actually, SNMP get there are many commands like SNMP get, SNMP walk, SNMP get bulk, like things. So those are implementations. Uh, Actually, this SNMP get is some command from SNMP tools. Actually, it is a command line based uh, SNMP client tools or manager tools. So we can easily install it in SNMP. We can easily install it in Linux or Linux servers. So here there's a SNMP down there's a SNMP walk operation. So normally it is we can say it is relevant to the here it's an get bulk request. It is an actually implementation of the get bulk request because SNMP walk command get multiple values of a tabular object. So as I said, there are two types of object. One is scalar object, has a single instance, and the other one is tabular object. It has a table or list of values. So this is the MIB then currently list of actually available MIB trees. So this left side that is here we can so uh, for example if here if entry that is interface entry, that means interface entry, it has sub objects like interface maybe interface name or like things. So if we want to get that information interface name, the particular object ID will be 0 1 and 3 6 1 and 2 1 2 2 1 and something. So the other remaining number hierarchical uh, other remaining numbers going down the hierarchy. So likewise, uh, uh, any in this example, this is actually standard original definition for an original set of MIB definitions. These are standard definition that when we install SNMP tools or in on Linux systems. So these MIBs are installed by default. These are inbuilt MIBs. So when think that we need to get information from Cisco devices or some HP devices or some other devices. So in order to get no, normally those particular vendor develop their own MIBs. Normally, they should develop their MIBs for themselves. Likewise, Cisco has developed so MIBs for their purposes. So for Cisco devices, if you want to get Cisco specific attributes, so object values, uh, object values, uh, we have to we can get those values through this hierarchy. That means we have to uh, get send a get request uh, using this OID, that is starting from uh, 1 3 6 1 4 1. If it is Cisco, it will be 9, again 9, and down the hierarchy, it will come to the particular object identifier. So also we can call it from the by the name. So it's okay. If also we can call like if it's say it's the command from SNMP get. So we have to specify SNMP get, and we have to specify the OID by either by name or by OID numbered version. So if we specify the textual representation, it will be ISO dot identifies the organization dot DOD internet, then dot private dot enterprise dot Cisco likewise. So actually these subtree the enterprise sub is allocated for enterprises, so corporate enterprises like Cisco, HP, Aruba things. So every MIB tree should be defined within this domain. So under this one, so for any corporate thing. But devices like most of the devices not only support these particular MIPS supported defined by themselves, but they normally support these standard inbuilt MIBs also. So within those devices, for example, if it's Cisco switch, uh, Cisco uh, Cisco developer has develop MIBs, MIB MIB has implemented MIBs relevant to these standard MIBs as well. So so these are some if you are using SNMP net SNMP client tools, that is we can install on Linux operating system. We can use this manager tool to test or get information from our devices, like the SNMP SNMP client tools support these commands. Maybe maybe each of these commands actually implement particular as I said, there were 7 operations. One of these actually implement that particular operation, like SNMP get of implement that get request, likewise SNMP get next implement uh, what is that yeah, get next request. Likewise, normally client tools has implemented each of the above set operations. So So using these commands, we can test actually. Once we configure, we have to configure SNMP in each agent device. Actually, normally though they don't straight away work, right? So yeah, in order to do that, we have to log into the particular device, and we have to do configurations on those devices. Uh, like we have to set the password and like there is something called community string. We have to set those things. So this is an example of some SNMP request or SNMP command that is sent to agent by the manager. So whatever here in Linux, if we install the SNMP tools, we can type the relevant SNMP command here, and then we can specify the particular version. Actually, this version should be configured and configured in the target device, so target monitoring device. Then we specify the community string. Actually, this is the community string is some basic level of authentication. It does not have actual username. Only have the it is like it is not like a username password, but only has some passcode. It is like a passcode, normal passcode without any username or something. So this here the community string is actually, or community string is a community. So this should be defined in the particular device being monitored. Actually, for example, as an example, we have set it as the community. Normally, it comes with the simple passcode like public, uh, but we prefer, actually we recommend always to have a normal strong password like passcode, like with comprised of special characters, like it's like it should be like a password. And we should specify here the IP address of the target first, and next the OID we need to monitor. That's a complete OID. So these are examples. There are several, I have shown here several variations of commands. In first command, I set SNAP get with version 1, that is the very oldest version. It still works. Uh, and it is community string net community, and IP address of the particular target device. Maybe the computer or router or something is this one, and the complete object path is object identifies string is this one. So using this, we can get that particular information. Also, if we can call it by the label name, right? Label name is actually the last part of the that OID textual representation. Well, as I said, yeah, here was the example. So as I said, ISO correspond to 1 and O correspond to 3 likewise. So this last part is the actual object name, or we also call it name. This is actually complete object name, or complete textual representation. So this is the OID. So actually it is very easy to remember this is name other than this OID. So that's why we are using those names, label names. here we can just define the label of what we need to have, but we should keep in mind that the particular MIB, that is the definition of that particular object or label should be uh, inbuilt, or it should be if it is a vendor based one like Cisco HP1, we should install it in our manager manager side. So like it's like a, we can say it's like a library. So if we call this if of a status, the if it is not important, that may particularly define this label is not imported in manager side, it will it don't have a way to know what if of a status means, but because it only understands this OID. So we if we actually this if of a status is actually inbuilt operation, so there won't have any issues. So it is actually defined in if MIB, that means interface MIB. So interface MIB is actually inbuilt or default MIB coming with the installation. So in next command, we'll call SNAP getNext. Um, we here we are using version 3, and we are using some actually authentication, some kind of a hash based authentication. And here uh, we have to specify the hashing function here, SHA or MD5 something, and we have to specify the that password. Then we have to specify the IP address. Then we have to specify the particular uh, uh, like OID or label name, or we can also specify here uh, uh, with its MIB name and uh, plus label name. Here's another example. Only we are going through version 2. Here we are using only version 2 to get the SNMP status. Actually it will show the up or down or some kind of status of particular device. Actually, in that example, we are not specifying that particular OID because this SNMP status by default should be calling that particular OID. So we don't have to specify explicitly what is the OID. Next, we come to SNMP versions. Now we'll see what are the differences of these versions. And version 1, which is actually released in 1988, which is very old one. No, in that it use actually basic authentication based on community string. And in version 2, actually the practical version is version 2C, and it has all the benefits that version 1 has, and plus it is implemented with the inform request, and so earlier one had the CRAP only version 1, and this one is implemented with the inform request, that the and it has also came with new data types like counters, likewise, and also it came with new retrieval methods like get bulk. As I said, there were 7 operations. In SNP version 1, there were few operations, and it has improved error handling, uh, and it has improved set commands. So also now the version 2 is widely used because in uh, still widely used in network management and tools. The version 3 is the major advantage is the security, and when we talk about security, we can talk about two phases, so three types of uh, three aspects about the security. One is the authentication. Authentication means uh, a particular user, known user should access the information. So in this case, it is user based, and it uses these SSJ and MD5 hash function for uh, for authentication. And when we talk about privacy, the uh, since it has the capability to encrypt messages using encryption algorithm like AES and S, uh, it has the privacy. So anyone in the middle or middleman attack will be in vain with this protocol. And third is the message integrity. Integrity means actually the whether if someone sends some message or some information stored will not be changed. So it will go to the destination or the uh, destination without change. So sometimes it can be was information change other than revealing it. Some maybe situation both are worst cases. So anyway, message integrity should be assured uh, so that here the message integrity has been implemented in this version 3. And also SNMP has views and groups something. Here it's like there are views in MySQL it's like that. In here views, uh, we get only information what we need. That means if we define a view, actually these views and groups are used for some kind of filtering by the particular device being monitored. So views and groups should be defined in network and server devices. So when these views are defined, uh, normally we can define a view like okay, there's no example here. Like we can only to control access to the particular subset of me. Imagine there are, but in a device router, the router has MIPS or router has capable to give information about maybe anything. So maybe device interface status and up down status like anything. But through views we can control what particular subset of MIB's object can be viewed by the manager. So we can limit this subset, like it's like yeah, we can limit to access view this only the status of the device, or it is whether it's we can restrict or restrict or limit to view the status of the interface status, like we can filter it. So views are used for that, and groups are used for filtering actually which set of which set of users. Uh, so we can group users, particular users. Actually, we can group. There are normally we can in a network and in a campus we have several users, like we have network admins or network super admins or normal, maybe a some trainee. If there's a trainee, we can have a guest account like that. So we can combine particular user accounts to groups like those things, and we can limit which group of users has can use we can view which part of uh, objects and MIPS like that. So we can also uh, filter access to the uh, particular object using these groups. So these are the primary security levels that is supported by SNAP version 3. First one is no auth, no free. That means no authentication, no privilege. That is um, sorry, no privacy. Sorry, and that means it is very similar. It does sorry, it does not have uh, authentication, and it does not have privacy too. That is actually it's very like the version 1 more version 2 security levels, like because it does not have authentication and privacy. Version 2 also like that, it does not have any authentication or privacy, that means encryption. So it is very similar to version 2 C and version 1. So in second one, authentication, auth no uh, means authentication, no privacy. That is, there's authentication that there we can set users and password uh, for uh, devices, but for SNMP, but there won't be any encryption. So in the fourth one, there will be both authentication and privacy. So access is authenticated, and also messages are encrypted. So if you implement, there will be some higher resource consumption, maybe depending on the device, device and number of operations. It will be significant for the particular device. This is actually some not a this I made this slide for some not a standard command, but for some to show that some formats of actually this is how we didn't talk about how to configure the SNMP in particular device has been monitored. Actually, SNMP should be also monitored in these devices. Uh, so when we are normally configuring SNMP uh, for example in Cisco, we have to enter command like SNMP server, and then we have to specify the community. If we are going with the SNMP version 2, we have to specify the community version. Then we can also specify view. It is very optional, uh, and Also, sorry, actually there's some mistake here. Actually, version 2 CR, as I remember, don't use views here. Sorry for that. And we can only specify the combinatorial string, and then we have to specify that it's read only or not. We can also specify the ACL thing. ACL. We can also specify ACL for access list. Uh, Access list for who can, which IP or which subnet can access these SNMP information. So normally we can specify here the only the server network, or we can specify the only the network used in the network operations and like those. So in SNMP version 3, this is some example format. Actually, this was made using combined commands from Cisco and HP. Maybe other vendors have different commands. So actually, and in Linux servers, oh, actually this is very different. It is not like this command, so it has different commands. And for SNAP version 3 configuration, uh, yeah, SNAP version 3 configuration, we can use this type of format. Normally, we can specify the version, and also we can specify the group here, and whether and what the privacy security level that we are going to use. That, as I said, there were 3 security levels. We can use any of these, and also whether it's read view or write view. Uh, so also and also we can specify the view. I said earlier about views and groups. We can specify the view here, and also we can specify the access control list here. And so this is some configuration with the passphrase password. So we specify here the group name and the authentication mode with the MD5 or SHA hashing function, and then authentication passphrase, that passcode we specify here, and the privacy mode, whether which encryption function is being used, and the privacy password. Privacy has also the some kind of passphrase or password. So by using, when we configure the device like this from client side, when you are using tools like SNAP get or SNAP get next, or whether we are using Nagios or Cactus for getting those information, we have to specify the same information specified here, like password or community string, like that. So this is, I think this is the end of this small presentation. I think this is just only a theory, but actually you can, I will show you some link, or actually we have done in a workshop last time. So it shows how to install uh, SNMP tools and SNMP uh, SNMP management tools and things, and how to request for information using SNMP tools, and how to configure SNMP uh, uh, groups and SNMP views and things. So hope you can see this screen, right? And this is the last year the presentation we actually workshop we did on solely on network monitoring. So it has a more detail how to here. I will go through this again. Uh, Actually, you can go to this. I think you can find this workshop. Uh, if you go to training 2021 net, yeah, workshop on network system monitoring. Go to agenda. So here we can you can see get the information about SNMP hands-on here. So here, okay, this is how that I said earlier we install SNMP manager tools or client tools. That is a network. If you want to make our computer network management station or NMS, we can install this. We can install this SNMP client tools using this command, and this will be the configuration file. Here we can we have to do these configurations to load the MIP file that is by default coming from the installation. Then also there are there are configuration files. This is actually the global SNMP configuration file for the manager, and this is for the personal. That is, if there are multiple accounts, Linux accounts, that will be the personal configuration file, user specific command file, configuration file. You can define the here the predefined user password and things. So here we can see here we can define that this is how we configure the SNMP agent. Earlier we saw how to configure the SNMP manager, right? That is monitoring side. Here the SNMP, how to configure SNMP agent on routers and switches. We can specify access list here as I shown here earlier, and we can specify the SNMP. Yeah, this is SNMP basic configuration with the community string and with the access list. And we can also go for with SNMP version 3 configuration. And yeah, these same things should be defined in the this same thing should be defined in the client side also for accessing. And this is some configuration example on HP router, HP, that is Docker or operating system. So this is how to define ACL and putting it with the some configuration command. And this is about SNMP version 3 configuration with the HP router. And this is for Aruba operating system, Aruba and Procovo operating system. Actually, it is some kind of wizard. If you are using Aruba access point, so you want to monitor Aruba, that is clients connected to that, what are the bandwidth use and things, you can go to the virtual control of the Aruba, or maybe the actually this is based on virtual controller. you can go to this command and configure the SNMP. So as actual physical Aruba controller may have a different path to configure this. And this is actual testing SNMP. Once you have installed, you have to test this with this command whether it's successful or not. Then yeah, this is some useful object IDs or labels or objects. So sysnames is services. So interface operating status. If operating status means, and this is how, if you want to monitor Linux server for its load of and CPU usage and things, processors or other parameters, we can install the SNMP agent component, or we call SNMP daemon, or the server side component in Linux. Here are the installation packages and commands, and yeah, this is the SNMP daemon configuration file. There we can configure the SNMP community and other things, and we can also define what port should be listening, and we can also specify some parameters, location or the syscontact, and what should be monitored. That if it's a disk, so all this. So also, yeah, this is the SNMP example of SNMP working command. I think there are also some MIP browsers. If you normally, if you want to think, you have the MIP, you have some different vendor device, but you want to get some parameter, some information. Maybe, for example, you want to get the IPv6 traffic, so you want to search it. You can also search on the actually web browser, but you can if you find the MIP, you can use MIP browsers. MIP browsers. Yeah, there are two MIP browsers, several, using using those. You have to first download the MIP file. It's a text file. Then put into this application some location, import it. Then you can browse it. Yeah, this is some example of yeah, this is a picture showing that the hierarchical tree of the MIP. So you can here search by OID. Maybe you can search by, you can also, there you can also execute that particular command here, get next, and you can test your, once you configure your monitoring device, you can test it here. You can discover, explore the what are the uh, objects you can have, so that you can monitor your network system efficiently, and yeah, you can find the useful variable using these things. Also, if you are looking for some Cisco MIPS, there are Cisco uh, MIP browser. If you have a Cisco device, you can search for MIP browsers. Yeah, search within the MIP browser, and this is the MIP browser. Yeah. Then you can find what device you have and choose. Then Yeah, you can, there will be shown a MIP3. Yeah, you have to get the Cisco operating system iOS version. Uh, then you have to set the enterprise, that license you have in your device. Then you have to, yeah, it shows the actually available MIPS, and I think as I remember, you can download it here. So yeah, okay, there you can actually browse the MIPS. Also, maybe other vendors also may have such kind of portals. So actually, using SNMP, normally we are also in Learn, we are also monitoring uh, institutional traffic and other things using SNMP. Uh, so I think this is, I think what I have to show you. I think this presentation is not enough, but that is scheduled to be. This is yeah. So in this workshop, we will only do the presentation. You can go through this hands-on to further get the information about this SNMP and how to use it. Things. So uh, any of you have any comments? So I hope you got something from this. Maybe it is too easy for you. think, next, actually, our session will be LibreNames, which is also mostly based on SNMP, and it also get information to be yeah, for monitoring through the SNMP. So if you don't have any comments or questions, I think we better to go for the next session. That Tuan will handle that. Over to you, Tuan. Hello. But The Mr. Palaratna has asked what is the legal situation to access SNMP in LAN routers. That means from your side or from our side? Actually, we have full ownership to access that, no? I think it's about they're asking about whether the institute can access it, no? Actually, institute normally can't access that. What YOLO means? Uh, Actually, normally we normally what you need from our access routers is, I think mainly it is bandwidth, right? Maybe, yeah, maybe bandwidth. Actually, we already provide it. And what else you want to know? You want to get from SNMP, from our routers? I think I have answered his question.
There is a one question, excuse me.
Yes.
So in a Cisco device, when you are configuring, when you are monitoring some, let us assume a layer 3 switch, we are assuming there is a one particular destination PC is connected to that one. Throughout the, if we wanted to find out which VLAN is using that port and what is the exact port, if this is the I mean, in the wall in the faceplate, if it doesn't mention the port number in the patch panel, so we wanted to find a switch port in a layer 3 switch. So without going through to log into that particular layer 3 switch and run a terminal monitor command, we can find it. Rather going through that process, is it possible to, if this layer 3 switch is in the Libra NMS, so it is possible to rather without going through the terminal monitor command through exactly logging into that particular switch. So through Libra NMS, is it possible to monitor whether this the particular switch is up or down status changes? That is my question.
That is, you mean there's L3 switch and devices connect to that, and you want to monitor the L3 switch whether it's down or whether another switch or whether connected to that one up or down?
No, if particular connectivity from
yeah,
to a
bit
rather
connected
going
from
through the
to
terminal monitor
another device.
Yes.
Another
Is it possible
device.
to trace the particular
Yeah.
port from whether
Normally
the port down
particular
from
port. I think we have to. I think normally it will return a tabular object, that is a list of interfaces, right? If you query for an interface operation status interface, right? Like interface status, whatever the object ID defined by the vendor, it will return a list of interface indexes with its status up or down. So I think you'll have to earlier know what the interface that particular your important device is connected to. That means if it is interface 2 that connected to a particular server, important server. So if you want to know that particular port 2 is down, you have to earlier know that it is belong to that particular that server, right? That means we can't from IP. I don't think because if it is if it is a router has an interface IP now. From interface IP,
So
we can
I mean, if
identify.
it is, I mean, it is if it is a switched, let us assume 24
Yeah,
port switch.
yeah. Then you have to identify. Actually, there's no way. Actually, normally, I think you have to predefine in your monitoring. You have to predefine port 2 is connected to this server. That will, and if the port 2 is down, you, you have to actually in your monitoring you have to monitor that particular uh, port 2 for that device. If you want to make sure that that particular server connected to that port 2 is up or down, you have to periodically or do polling for that particular port 2. Now, not all of the port. All if we get all of the port, actually we can't identify which port is connected, which port is connected to that server. So anyway, you can do that. So that's how you will have to do that. Did you did you get my answer? Hello, Mr. Chamikar.
Yes, 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 yes.
Yeah, I think you just have to particular. Yeah, then you when you are entering the OID, you have to put the particular index. You have to prepare. You have to add at the end, and at the end of the OID, you have to add that particular index, whether it's 0, 1, or 2. Normally, indexes are beginning from 0, no, not 1. So for a 24 switch port, there will be 0 to 23 indexes. So they have to monitor the 1 index 1 for 2. Uh, so yeah.
Yeah, if it is possible, I'll try.
Yes. Yeah, if any problems, I can help you. Anyway, put yeah, text me or call me. I think you can find my number from the website, so I can help you.
Okay, thanks.
Okay. Any comments? Okay. Next will be Tuang's session on installing LibreNMS. I think I should hand over to him. Thank you very much.
Good morning, everyone. I think everyone can hear me, right? Right. Okay. I think you got an idea about SNMP and also the previous sessions also. And I think you guys set up the network and all the Dynagen and everything is working up to now. And if there's anything, we are here to help you guys. And so the next part is to do the network monitoring session. And so even if you go through the agenda, you can see the sessions are available. I think everyone can see my screen, right? And in here, so this is the final day of our workshops, and so the setup a guide is available, and also the slides are also available, and you can download it and you can view it. And so from now onwards, I will start my slides about network monitoring. So everyone, I think everyone have an idea about what is monitoring and what is a network. So I'm not going to talk about the basics and here. So first we'll start about what is network monitoring. Even I think everyone can visible the my sharing, and also you can even read it also. And so it's kind of a monitoring. That means that if there is something happening in the network without knowing, I mean, with knowing or without knowing, then you have to find out what is happening inside the a network. So as administrators, system admins, you will get many complaints from the users that the network is slow down, or else the things are not working, or else you cannot access internet or something like that. So I think everyone are facing those kind of issues daily. And so it's a monitoring. So to have a by having a monitoring system in a network, so it is really easy to handle all the situations. So as a network monitoring, it's constantly or periodically monitors a computer network for slow failing components. And so from a network monitoring system, it will notify, and or else even you can log in and you can see all the cases, outages, or other troubles using a network monitoring system. So it's kind of a easy thing for having a network monitoring system. And for the network administrators, it is very useful system for use. And so the next one is why use a network monitoring system. Yeah, as I mentioned earlier, and also in here also you can see in bullet points, there are a few things I have mentioned in this presentation. So you can optimize network performance and availability, and stay informed, diagnose issues, report issues, eliminate a need for manual checks, proactive approach, and track trends. From these are just a few tasks that I have mentioned in this presentation, but there are more than tasks available in this slide. So those things also you can manage and monitor by using a network monitoring system. And the next one is how network monitoring system works. So there are different types of protocols available in the in network monitoring. So in network, so you can use SNMP, ICMP, or SNetFlow. Those are some protocols. So those things are using for monitoring and collect data from devices periodically and set up a baseline, check if the data values with the baseline, and notify if the values are below the baseline. So using different protocols and using in the network monitoring. So that's how the system works. And there are some monitoring tools available. So there are two categories, such as open source and commercial. So most of the commercial products are based on license, and you have to renewal in yearly wise or else monthly wise, like that. As you aware, you can purchase those things. And also for the open source, you can download it and you can set up the monitoring tool and you can run it. So open source, for example, LibreNMS is available, Nagios is available, and Cacti and Zabbix. Those are some open source monitoring tools available to purchase. And also for the commercial, Microsoft Network Monitor is available, and PRTG and GFI LandGuard. These are some mention commercials in this slide, but there are many more commercial monitoring tools available in the market. So as you wish, with your requirements and all, you can download it, and or else you can purchase it and you can run through your network. And when selecting monitoring system, so these are the things that you have to consider. You have to consider about the model, deployment model, and the ease of use, compatibility with existing network infrastructure, and system scalability, and interoperability. Also, you have to consider when selecting a network monitoring system. So by maybe there are more consideration when selecting NMS. So you have to think about those things also. Then if you have you have to decide whether you are going for an open source one or else a commercial one. So then you have to think about those things and the budget and everything. And so how fast you have to deploy a monitoring system like that, you have to think, and you have to consider all those things. And after that, you can select an NMS for your network. So in here, we are going to talk about LibreNMS. So as it's open source software, you can download it from the web and you can install it easily without any hesitation. And also the guides are also available in the internet, and also there is a big community. So by with the big community, you can have you can have the communications, and you can discuss the things, you can share your knowledge, or else you can gather knowledge from others, and you can have a big community. So you can have the discussions and everything you can done through with the LibreNMS community. So for the LibreNMS introduction, so it is an as the earlier Lalanta said, it's a SNMP based network monitoring system. So it's based on AutoDiscover network monitoring, and derived from ObsVM, and also it's a web application written in PHP. So it's easy to handle and no need of big knowledge to have such web application. I mean, it's really easy by looking at all the dashboards and the tools by looking at, and with the community LibreNMS community, you can easily learn about LibreNMS, and also so it's freely available in the internet, and even from the YouTube also you can search for the things that you want to know, and it's have a big community, and also includes supports for a wide range of hardware. Yeah, so it's it's like you can it's supports for different hardwares to installation purposes. So you don't need to worry about much about the hardware, but anyhow with the minimum requirements, so you can install it the network monitoring tool. So when consider about the technical overview, it's a Linux based one, and it's a real-time interface traffic graphing. So device inventory collection, and it's detailed with IP version 4 and 6. TCP and UDP statics is also available, and BGP border gateway protocols and OSPF information, and MAC and IP addresses information. Application monitoring using SNMP and integrate with other tools also. So these are some technical overview, or is from the internet also you can study about more about this about technical overviews. So these are some features available. These are some features I have mentioned in the presentation, but there are many more. And so mainly you can see the dashboards and the status map extensions also available. So you can install it and you can run it through those things, extensions, and host monitoring supported check and support scripts and billing module. Integrated with other tools means smoke pin collected syslogs and receive logs from devices. Also, those things are available. Also, you can connect to notification also for your mobile phone or else some other. Last time we connected LibreNMS with the mobile phone application like Telegram. So whatever the things that going through the network, it automatically indicates and it send a message for your Telegram application. So by looking at those things, even from that one, you can identify what is going on through the network in your network and what is happening, and all the devices and everything is updated through Telegram. So even those things also can, as an advanced features are available in LibreNMS. And when we talk about the philosophy of LibreNMS, there are some things I have added in the presentation. You can go through those things and approach that network monitoring should take long to set up. And you already worked hard to build network and configure it. So LibreNMS is easy to understand if you understand it philosophy. And it's not that much complex system, it's a simple one. So if you know the philosophy well about those things, then it's easy, you can easily understand what is happening inside and configure equipment correctly, community and systems, locations, those things, and LibreNMS will do the rest. So it means auto display of devices and resources, option use of sys services, map which services the ports are running and on a device. That's what's happening there. It's what about the sends and receives of data, those things, and concept of enabled is ignored by default. LibreNMS will monitor all ports interfaces it finds and also configure to be up, operationally up, and it will complain about it and ignore the ports, or better shout them down if they are not used. So when they are used, bring them up. So also it will check all the ports and interfaces, and so it will monitor and it will collect the data and it will complain. So those are some philosophy about LibreNMS. So up to now, so that is the presentation, and I will go through the agenda. Yeah, I think from the lab setup, I guess you guys have downloaded the web server and the Windows XP inside and Dynagen. Those things should be on run, and after that to access to the LibreNMS, I think better to use Windows XP. And also in the program lineup, we have added the session videos, and the day 3, the yesterday one, will be uploaded soon, and it will be also available in the agenda. And also I have to mention that for the monitoring server, the IP should be added, and for that one, first you have to, I think we already gave the LibreNMS copy, so you don't have to worry about it, and the username and password is available. Yeah, username is user and the password is 1234. So once you log in to the monitoring server, then you have to run, you have to configure the YAML file, and you have to set the IP addresses. So otherwise, your monitoring server will be out of your network, so there will be some issues to access it. So first, so I think you already have the file, and after that, so in here we are going to use Nginx. If you really want to use Apache, or so in LibreNMS website also it's available, but in here we are going to use Nginx. And for the login purpose, you have to log in using this username and password, and after that you have to login as root. So we have to use sudo su for login purpose. So first, okay, first of all, I will go through the setup, the installation guide, and after that you can set the password, the IP addresses, and then we can process, we can continue with the installation. So first you have to install all the properties, and after that repositories, and in here you can run through these things in the monitoring server. And after that we are going to add a user for the LibreNMS, and after that you have to change the directory to opt, and after that you have to clone it from the git. And after that, setting up the permissions, this thing should do, otherwise sometimes the write permission and read permissions errors will be available. So before that one, you have to use setting these permission for LibreNMS. And after that, we have to install the PHP dependencies. So for that one also, you have to once you adding the user, then we have to use the username, and after that you have to run the script. Sometimes the PHP error will come for sometimes, or if you have a kind of error running this script, then you have to run this one, or else by looking at the error you can install it anyway. It will show what is the error and what should you do next. So if you know to do next, you can continue with this one, or else if the above script is failed, you can use this one. And in here you have to see the time and date. So in here I have given time and date one website in Asia, I think. Yeah, we have to give Asia Colombo for the time and date purposes. So in here you can use any editor, maybe VIO, Nano, whatever the editor you can prefer, you can use it. And you have to edit these files, and in there you have to find the date time, and you have to remove this one, and after that you have to add the date time in here. After equals there will be empty, so we have to add Asia Colombo and we have to save and exit. And same like that for the PHP 7.1 this one, and for the CLI also you have to do the same. Once you done, then you have to set the time zone, and after that in here etc/UTC means in here again you have to use Asia Colombo in here. Once the time zone is okay, then you have to go through, we have to configure the database. So we are using this MariaDB in here. So again, you have to use VIO Nano to edit this one, this CNF file. So in here you can use VIO or else Nano. Once you open that one, then you have to add these 2 lines within in here. It means that MySQL D will be available with the square brackets, and after that you have add these things, not inside in here, below that one you can add these things. And after adding the above 2 lines, you have to save and exit, and then you have to enable and restart the MariaDB. So in here systemctl, first we have to enable it, and after that we have to restart. So once you configure the DB, then after that you have to log into the database using MySQL as a root, and after that you have to create a database called libnms, and after that you have to create a user and you have to give the permissions, and then the database part is done. And after that the configuration of PHP FPM, and in here you have to copy these things, and after that we have to again you have to edit this libnms conf file, and after that once you edit this file, the www within the inside the square bracket there will be available, so you have to change the www into libnms. Then after that it will be shown like this, and after that these user and group, these things will be available, and also it will be available like www dash user or else group or something like that. So then you have to edit it to libnms for the user, libnms, and for the group also libnms. And after that in the same file you have to comment this one, and after that you have to add this line. Some of these will be confusion, but I will show how those things are done using the terminal. And so the web configuration part, then after finishing the PHP FPN part, then you have to go to the web configuration. Once you successfully completed the above one, then you have to edit the configuration file again using VIO Nano, and after that you have to add these things. So in here we have used learn as an example, so you can use your institute name in here, and please remove this one also. If you are copying, just remove this part, so otherwise it will show some other errors. So then you have to restart the Nginx and PHP, and you have to run these 2 lines for restarting Nginx and PHP. And after that to enable the completion. So we have to run these two commands and configure SNMPD. So you have to in here you have to edit this snmpd.conf file, and so using vi or else nano. So in here there will be a word called random things goes here. So in there you can set your own community string in there. Just delete this one and you can add what the things that you like to add. It means a community string. And after that, these things has to be done. And then we have to put the cron job. By running the script. And the copy log rotate config. And after that, you're almost there. Then the web installer. This config.php. Then after that, you have to use the Windows XP inside, and then you have to use the IP address. I mean, in here, in the network setup, there will be the IP address will be available. I mean, once you set up this one, then you have to use that one, use your browser, then you can load it. Then before that one, you can troubleshoot whether the LibreNM is in here, the database and everything is validated or not. So if you have any issues, then you have to go through those things again, and then you have to check it. Then once you are okay, once the troubleshooting is okay after the validating, you can use the final step. So logging, then once you use the IP address and the browser, this window will appear. It's the PHP file will appear, and after that, by here you have to check the database and the password, username, and after final setup. So in here, the username and password, you have to use the same username and password in there. And after that, you have to create a user. You can add a new user for the LibreNMS web interface. And after that, it will finish, and then you have to validate your installation. In here, you will see a hyperlink called validate your install. Then if you have any errors, it will shows. And if you by looking at those errors, you can configure those things. Then you have to once you validate your install, automatically after validating, login page will be available. And then in here you created the user admin user, so in here use your credentials and you have to log in. Then you can add devices. You can use your hostname or IP, and after that you can add devices. So once you done, so this will be the available LibreNMS setup. So in here you can add devices, and the dashboard is here. So in here also you can add, you can edit, you can do dashboard names. The widgets are available, so you can add different widgets for quick view. So those things you can customize it, and also those things you can use using LibreNMS. I think you guys already downloaded the network setup files, I guess. So once first we'll go through for the configuration of YAML file. So first we'll set up the IP addresses and we'll continue. So up to now, is there any questions? I think for those who are already, I think 2000 last year or else before, we did Librain MS in the network monitoring workshop. So in there also we discuss these things. So if you have any other clarifications, please ask, or else you can use the chat section and you can type it. Okay, anyone who's willing to share their screen with us? So for those who are doing, so we can discuss, we can have a chat while going through the installation session. Right. Yeah. Another thing. Before doing that one, once you downloaded the web monitoring file, then you have to go to the agenda and day 2 lab setup, and in there you have to check this one, adapter one, UDP tunnel, and these things are available or not. Otherwise, there will be some issues while configuring. There is a question that's rather going through CLI. Is it possible to start configuring straightly from web interface? No. The thing is, first you have to install the base, then only you can go through the web interface. Otherwise, there's no way to skip the first part and straightly go through the web interface. For the web interface purposes, why that's we are building all these the database and everything. Otherwise, there will be errors. First, we have to add these things for the web interface purposes. So until to the web interface, you have to solve the PHP dependencies. The thing is that this web interface is using PHP and everything. So the database also should be there. Otherwise, there will be issues. So is there any other questions? It's almost 11:58. So guys, there will be some issues if you are not configured the previous parts. I mean, from the pfSense and the other network, and so first thing is that you have to configure all those things the earlier sessions, and after that we can run the LibRainMS. If you are if you want to install only LibRainMS, then we will continue it after the lunch. Right, guys. So we'll stop for the lunch break, and we will be continue the setup after the lunch break.